Hi everyone, welcome to EdXP. EdXP is a learning and assessment platform for students to test and practice outside of their classroom. Today I'll be covering the topic of permutations and combinations, which is an important topic in the subject of IBDP Mathematics, Analysis and Approaches, higher level. So this topic is not in the standard level. So let's jump right in. I will be covering a total of 5 questions in this video. And the first 3 will be from past papers, and the last 2 are questions from our EdXP database. So feel free to try them online. So let's jump right in. This question over here actually came out in the May 2017 Time Zone 1, Paper 1, Question 4. For 5 marks, 3 girls and 4 boys are selected randomly on a straight bench. So we have 3 girls and 4 boys. So always remember in P&C questions, people are unique individuals. Okay, find the probability that the girls sit together and the boys sit together. Okay, so how I like to do this is to illustrate on a diagram. So we have 3 girls sitting together. So girl 1, girl 2, girl 3. And we also have 4 boys sitting together. So boy 1, boy 2, boy 3, and boy 4. Okay, if they're seated together, we use what we call the combined object method, okay, where I group the girls all as one object, and the boys, since they are seated together, also as one object. Within the first object, the 3 girls can arrange themselves in 3 permute 3 ways, or also known as 3 factorial. Okay, always remember that the girls are unique. If the question was 3 green balls, then they are all identical. So in that case, you don't need to do permutation. For the 4 boys, we can arrange them in 4p4 ways, 4 permute 4, or 4 factorial, same thing. Okay, and since they are seated on a straight bench, there are 2 ways to arrange the girls and the boys, either the girls and the boys or the boys then the girls. Okay, so this will be 2p2 or 2 factorial. Okay, and using the multiplication principle, we multiply them together, 3 factorial times 4 factorial times 2 factorial. Okay, but we want to find the probability. Always remember that probability is between 0 and 1. Okay, so what we need to do is to divide it by the total number of possible arrangements. Since we have a total of 7 people, we will do 7 factorial, which is the total number of possible arrangements under a no restrictions case. Okay, and since this is paper 1, we can actually do this without a calculator. So we have 3 factorial times 4 factorial times 2 factorial. I would like to change this 7 factorial to 7 times 6 times 5 times 4 factorial. Okay, in which I can cancel off the biggest numerator over there. Okay, I can simplify this. So 3 times 2 times 1 times 2 divided by 7 times 6 times 5. Okay, so I can divide 3 with 6 below, simplify, and 2 with 2. So my answer is 2 over 35. Okay, I hope you got that question. I'll move on to our second example. This question was taken from the May 2017 Time Zone 2, Paper 2, Question 8. Okay, so GDC is allowed for this question. So let's analyze this 6-mark question. In a trial examination session, we have to take 18 examination papers, which includes the physics paper 1, chemistry paper 2, and biology paper 3. Okay, so we have physics, chem, and bio papers out of the 18 papers. No 2 of these 3 papers may be taken consecutively. So this is the most important line here. Okay, the next line says there is no restriction on the order in which the other exams may be taken. Okay, but when we see that no 2 of these 3 papers are to be taken consecutively, we apply what we call the slot method. Okay, when we want to separate our objects. Okay, so let's try and do this. I always like to do a graphical representation. So when I want to separate papers, physics, chem, bio, I ignore them first. I focus on the rest. So we have 15 papers left. I will arrange them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 papers that are not physics, chem, or bio. Okay. And I want to slot these physics, chem, and bio papers in between all the other papers. Okay, this is one of the best methods to separate all our objects. And if you notice, we can have a total of 16 slots. Okay, so on the top, for the rest of the papers, I can arrange them in 15 ways. Okay, or 15 factorial. And at the bottom, I have 16 slots, and I would like to permute or arrange 3 papers, the physics, chem, and bio papers. Okay, so using the multiplication principle, 15 factorial times 16 P3. Okay, since this is a paper 2, I will proceed to use my calculator. 15 factorial times 16 P3, which will give me quite a large number here, 4.39. Let's leave it to 3 significant figures. 4.39 times 10 to the 15, 3SF. Okay, I'll move on to our third example from past papers. So this question actually came out in a very recent May 2021, Time Zone 1, Paper 1, Question 9. Okay, and this is an 8-mark question, quite a lot for PNC. Okay, so let's have a look at this question. A farmer has 6 sheep pens, okay, 6 sheep pens, as you see over here, arranged in a grid with 3 rows and 2 columns as shown. Okay, so these are the sheep pens, but we have 5 sheep. Okay, Amber, Brownie, Curly, Daisy, and Eden. So A, B, C, D, E to be placed in the pens. Each pen is large enough to hold all of the sheep. Okay, Amber and Brownie are known to fight. Okay, that's quite interesting. So for part A, find the number of ways of placing the sheep if each pen is large enough to contain 5 sheep. Okay, so one pen can have all 5 sheep. But Amber and Brownie must not be placed in the same pen. Okay, how do I approach this question? We have 5 sheep, 6 pens, A, B, C, D, E. Okay, 5 sheep, 6 pens. If Amber and Brownie cannot be in the same pen, then if A goes here, then B only has 5 options. If A goes here, same, B only has 5 options. Okay, I hope you know what I'm saying. So if let's put Amber first. Okay, so sheep Amber has 6 options, but Brownie has only 5. And the rest, I believe, have only 6 options. Yeah. Okay. So since this is a paper 1, I think we don't need a calculator. It's 5 times 6 to the power of 4. Okay. So that's the answer for part A. Part B. Each pen may only contain 1 sheep. Okay. So we have 6 pens, 5 sheep. There'll be one empty pen. Okay, there could be one empty pen. Amber and Brownie must not be placed in pens which share a boundary. Okay, we have this new term here called a boundary. So let's define them. We have one boundary here, second one, third one, fourth one, fifth one, sixth one, and 7. So we have a total of 7 boundaries. Okay, when I look at this question, I might want to attempt what I call the complementary method. Let me explain why. Because it's probably easier to do the no restrictions case, and we subtract off the cases where A and B share a boundary. Not many cases, so let's have a look. For the no restrictions case, no rules, okay? Anyone can go anywhere. We have 5 sheep, so we have a total of 6 factorial ways to arrange all the 5 sheeps and 1 empty pen. Okay, and we subtract the case where A and B share a boundary. Okay, for them to share a boundary, we know there are 7 cases. Okay, and we multiply them with 2 factorial because we can swap A and B around. Okay, And for the remaining sheep and the empty slot, we can multiply by 4 factorial. Okay, so if we were to simplify this, this would be 6 factorial, which is 720, minus 7 times 2, 14 times 4 factorial. Okay, that will be 336. And the answer will be 384. Okay, and that's the 3 questions from past papers. Let's move on to our EdXP database. So this is one example. This is in our PNC training mode. Okay, so we're at a level 2 question. So level 2 questions are for practice, just one level before the IB difficulty level. The school softball team comprises 15 boys and 18 girls. Okay, so we have 15 boys, 18 girls. Find the number of ways such that the CCA committee contains 3 boys and 4 girls. Immediately, you must identify that this is a combinations question. Arrangement is not important, so we don't use permutations. Okay. From 15 boys, I want to choose 3 boys for the committee. And, okay, when we say and, we multiply. Okay. 18 girls, we want to choose 4 girls. Quite straightforward. Okay, since this is a paper 2, 15 choose 3 times 18 choose 4. The answer is 13,923,00. So the answer is D. Okay, hope you got that. I'll move on to the next question, our last question for this video, also taken from our EdXP database. Feel free to try them online. This is in our training mode, also level 2. The school's string orchestra comprises 5 cellists, 7 violinists, 8 violists, and 1 pianist. Find the number of ways a team of 8 can be chosen from the 21 individuals for a club bonding session. Immediately also recognize that arrangement is not important, so we use combinations, not permutations. We have a total of 12, 20, 21 musicians over here, and we want to form a team of 8, so that will be 21 choose 8 for a club bonding session. Okay, so that will be 203490. So the answer is D. So that comes to the end of this video. Please feel free to try these permutations and combination questions at edxp.com. See you again. Thank you.